Hello, welcome to the homework review for homework 1.4 using a chip model. ACE problems 32 to 38 on page 18. So remember in class today we talked about using chip models, that you can use red chips to represent negative numbers and black chips to represent positive numbers. If you then put your red chips and your black chips together to model a problem, for example, owing $6 is 6 red chips, getting $4 is 4 black chips. If you put the 6 red chips and the 4 black chips, the 4 black chips cancel out with 4 red chips, and that leaves you 2 red chips, or negative $2. So that was the idea behind our homework today, is reviewing some of those examples. So find the missing part for each situation. Well, if we start with 3 black chips, that's positive $3, and we add 5 red chips, or take away $5, 3 of our black chips match up with 3 of our red chips, which leave us 2 red chips left. So 2 red chips, or negative $2. If I have 1 red chip and 2 black chips, but I need to subtract 3 chips. Well, subtracting 3 chips, I only have 1. So how do I get 3 red chips? So remember, if I need 2 more red chips so I can subtract them, I can just add 2 more red and 2 more black. Because adding 2 red and 2 black, they cancel each other out, so it's not really changing anything. So in order to subtract 3, I have to add 2 more red and 2 more black. So then I would have 3 red and 4 black. I take away the 3 red, that leaves me with just the 4 black chips. This one I have 5 red chips to start out with, and I need to end up with 2 red chips in the end. There's 2 ways you can do this. You can just take away 3 red chips, so 5 red chips minus 3 red chips gives you 2 red chips. Or you can add 3 black chips, which will cancel out the 3 red chips and still leave you with 2 red chips. Here we don't know what we're starting with, but we need to subtract 3 red chips to get 4 red chips. So basically, you're subtracting 3 and giving you 4 is you need to have any combination that will give you 1 red chip. So I could say, well, 1 red chip minus 3 will give you negative 4, but make it even easier, we'll say, so to think about it easier, if you want to have 4 reds when you're done, so we can start off with 4 reds and 3 blacks. So 4 reds and 3 blacks, subtract the 3 blacks, that gives you 4 red. You could start off with 5 reds and 4 blacks, 6 reds and 5 blacks. Doesn't matter, as long as you end up having 1 more red chip. When you subtract the 3 black, then you'll end up with 4 red. Okay, in this example, write a story problem for this situation. Find the value represented by the chips on the board. So first of all, we have 5 blacks and we have 8 reds. So what could it be a story problem for that? Well, we've earned $5, but we owe $8. So my example is Julia earned $5 mowing her neighbor's yard, but she spent $8 on gas. Or negative 8 plus a positive 5 gives me a negative 3. I'm still 3 in the hole. I owe 8, but I only have 5, so I still owe 3. For exercises 37 and 38, use this same chipboard that we have up top. Describe 3 different ways to change the number of black and red chips, but leave the value on the board unchanged. So I have 5 red and I have 5 black and 8 red. So it means our value is negative 3. What else can I do to it to leave it as negative 3? Well, you can just keep adding the same number of black and the same number of red, and that won't change the value. If I add 1 black and 1 red, that's still 0. 2 blacks, 2 red, that's 0. So if you keep adding the same number of blacks and equal number of reds, you won't change the chipboard. The idea is those opposites. You want to add opposite values, because an opposite, like negative 1 plus positive 1 equals 0. Negative 4 plus positive 4 equals 0. If you add opposites, it won't change the value of the chipboard. Our secret word for today, since we're thinking about taking a little pause here, our secret word will be vocabulary, because if you haven't finished your illustrated vocabulary, you need to finish that. So vocabulary is our secret word. Okay, again, we're using this chipboard. We're starting with the original board. What's the new value of the chips on the board if I remove 3 red chips? If I remove 3 reds, so these are completely gone, 1, 2, 3, then that leaves me with 2, 4, 5 red and 5 black. So that actually cancels everything out, so my value is 0. Pause. Okay, so I'm going to leave it the way it is. I have 0, and I'm going to add 3 black chips. Adding 3 black chips is going to give me a positive 3, because I was at 0. So that means I'd have 8. I removed the 3, so I had now have 5 red and 8 black, gives me positive 3. Now I'm going to add 200 black chips and 195 red chips. Really adding 200 black chips and adding 195 red chips is just adding 5 black chips, because 195 red chips cancel out the 195 black chips. So that just leaves you with a positive 5. So if we had positive 3 and we're adding positive 5, then we're left with a total of positive 8. If you had trouble doing any of these, use your own version of red and black chips, like just draw on paper with red and black or make up your own at home. It really helps to have that hands-on using of the chips to help you. All right, that's it for the homework. Thank you. Bye.